Hello everybody, this is Philip Jonas at Kalamazoo Valley Community College presenting OpenStax Principles of Economics, and today we're covering section 5.1, Elasticity. In this module, you will learn how to calculate the price elasticity of demand and how to calculate the price elasticity of supply. So, what is elasticity to begin with? Elasticity is a concept that pops up in economics whenever we want to measure how one variable responds when a second variable is changing. For example, we will spend a lot of time talking about the price elasticity of demand, which measures just how much the quantity demanded of a product changes when the price of that same product is also changing. Now, the reason we are using elasticity here is that ideally we want a measure of responsiveness that does four things for us. Number one, it should not change with the direction along which we are going a curve, because the demand and supply curves don't have directions. So if we have one economist going from A to B, a second one going from B to A, and they get different results, that will be a bad outcome. Number two, we want our measure to not change if there's a change in units. For example, if we are looking at a product that's being sold individually or in a six-pack, we can't end up with a different measure of sensitivity. Or for example, if we're looking at two different currencies for the same product. Number three, and this will come in a little bit later, we want this measure to be equal to 1 for any 2 points where revenue is equal. That's going to be very handy. And then finally, we would really like this measure to work even if we don't know the underlying equation for our demand curve. So of course, we want to be able to calculate it off an equation, but if, as is often much more realistic, we instead have a few measured points of prices and quantities, we want to go ahead and calculate our measure just using those points. So let's go ahead and have a look as to why we don't use regular slope. I mean, ultimately, when we talk about responsiveness, we're talking about the shape of a demand curve, for example. And if I tell you here's a line on a two-axis graph, give me a measure that describes its shape, you would probably answer slope, and that's a really good answer for many applications. So slope, of course, in this case would be taking the change in quantity demanded and dividing it by the change in price. At least if we're taking the dependent variable quantity demanded, dividing it by the independent variable price. Of course, because the independent variable is sitting on the y-axis in economics, you could argue that in terms of looking at it, the slope should actually be delta P over delta quantity demanded. But let's not bicker about that because we're not going to use this measure anyway. Why not? So slope has many desirable properties. For example, the measure doesn't change with the direction, and we don't need to know the underlying equation for demand. But slope is sensitive to changes in units. So if we have a product that we are measuring in, let's say, pesos for one country and dollars for a second country, even if consumers are behaving in identical ways, we would end up with a very different slope simply because there are so many more, let's say, Mexican pesos to one United States dollar. So how do we get around that? Well, if we want to get away from the problem of units, there is another measure in mathematics called elasticity. For example, here you see on the right a very fancy looking equation for the so-called point elasticity of a function. And it does a lot of stuff for us. It doesn't change with the direction, just like slope. Great. But it's also not sensitive to choice of unit. And why that isn't the case, I'll show you with our actual measure in just a minute. And finally, it has this desirable property that it's equal to 1 when two revenues are the same number for two different points between which we're calculating this point elasticity. But the point elasticity does have one disqualification as well. In order to calculate a point elasticity, if you're looking at those funny looking d's there in the equation, those are partials out of a derivative. In order to calculate those, we would need to know the equation for the demand curve. So that's great if we're constructing a theoretical mathematical model. But if we want to apply our measure of elasticity, if we have a couple of real-world price and quantity points, well, now we would have to fit an equation using some sort of regression method, and then we calculate a partial derivative based on that estimated equation. It's not great. We'd rather calculate something directly off those points. Also, as a side note here, obviously this would also mean that for the point elasticity, we need to know calculus. So let's just not do that and go ahead and advance to the next slide. So instead, what we are going to be working with is what's referred to as the arc elasticity. It's very similar conceptually to this point elasticity, but as opposed to working out the measure for one specific point in an equation, we are going to work it out between 2 points along this equation. So even if we don't know the underlying equation, as long as we have 2 points, we can calculate an arc elasticity for us. And it does all the other things for us as well. It doesn't change with directions. It's not sensitive to units. Why isn't it sensitive to units? Because instead of calculating the absolute changes between the variables, like you would with a slope, rise over run, so to speak, we are instead calculating relative changes, percentage changes. If you tell a friend how you did on the midterm, if you tell your friend 40 points, well, that's not informative without the unit. Was that out of 50, out of 60, out of 100? But you tell your friend that you earned 80%, that takes the units out of the equation. It's a relative measure to begin with. So everything is great with arc elasticity, except one tiny hitch. In order for it to hit all 4 check marks, when we calculate the percentage changes, we have to calculate them using a very specific method called the midpoint method. And you just might not have seen this midpoint method before. So let's go ahead and talk about percentage changes. So when we talk about percentage changes, we're talking about moving from one number to a second number. So for our example here, let's say we've got a variable x and it's changing from start value 4 to end value 6. Okay, so traditionally, when you calculate a percentage change here, what I'm going to call the normal method for a percentage change, what we do is we take the difference between these two numbers and divide it by the start value of those two numbers. So we're going from 4 to 6. Normal formula for percentage change. We take the end where we arrive, 6, minus the beginning, 4, start, and then divide by the start. So let's plug that in. In our case here, 6 minus 4 over the start value 4. Notice I've got the start value in red. That's because that start value is about to be quite important. But first, let's just do this example calculation. So 6 minus 4 over 4, that's of course 2 over 4. Or if you express that as a decimal, you're looking at 0.5. And then finally, of course, we want to go ahead and convert that into a percentage change. So depending on how you learned how to do that, maybe you were told to move that decimal point 2 spots to the right, or maybe you were told, hey, percentages that represents out of 100, we are really constructing a fraction here, so 0.5 is the same as 50 over 100, or maybe you were taught to multiply by 100%. However, you were taught to get there, 0.5 converted into the percentage representation, 50%. So that is the ordinary method of calculating a percentage change. And it's not quite what we use to calculate this arc elasticity in economics. Instead, we are going to use the midpoint method. So first of all, what's a midpoint? A midpoint is simply the middle between two numbers. So in general, we take the sum of our two numbers, divide by 2, get the average, done, that's your midpoint. So really, what the midpoint method refers to is that when we calculate our percentage change, instead of taking the difference between two numbers and dividing by the start value of those two, we're instead going to divide by the midpoint, the middle of those two numbers. Let's go ahead and work that out. So once again, working out the percentage change between the exact same two numbers here, 4 to 6. We are still calculating our difference as 6 minus 4. The difference is we're going plus 2 on the variable x. But instead of dividing by 4, notice here in green, we're dividing by the middle. We're dividing by 5. So in this case, we would have the difference 2 over the middle 5. That's 0.4. Or after we do our conversion, 40%. So we got normal percentage change method. We got midpoint method. For elasticities in economics, always use the midpoint method. Even if you're not told, that is just the standard way to do it. So at this particular point in time, of course, we're going to practice this in just a minute, you might be thinking to yourself, but why, right? But why? It has to do with sensitivity to direction. So again, demand curves, supply curves, no start, no end. So let's say we have another economist looking at the numbers 4 and 6, but that economist instead goes the other way, from 6 to 4. So let's go ahead and execute the normal percentage method first. Difference over start is the formula. So the difference this time, end value 4 minus start value 6. 4 minus 6 is, of course, negative 2. But our start has changed. We're now starting at the number 6. So 2 over 6, that's, of course, approximately 0.33. Or, once converted to a percentage change, we are looking at a 33% decrease. So again, same two numbers. When we were going in the increasing direction, plus 40%. Going in the decreasing direction, minus 33%. We can't have that. We can't have that. We need it to be invariant to direction. So to the rescue, the midpoint method. The midpoint method uses difference over middle. So once again, let's check it out. For the midpoint method, we're of course also doing 4 minus 6. It's still a minus 2 change in the quantity, but we're dividing by the middle of our two numbers. Middle between 6 and 4, still 5. The middle of two numbers doesn't change with the direction you're going in. You get a consistent result. It's still 2 over 5, so it's still 0.4. It's still 40%. The only difference is, do you have an increase plus or do you have a decrease minus? All right, we can work with that. So this is our midpoint method. And by itself, well, it's not that big a change from a regular percentage change. Difference over middle instead of difference over start. But when calculating an elasticity, we have to do that twice because we're looking at the percentage change in one variable divided by the percentage change in another. So let's go ahead and just practice this a whole number of times during our lesson here. So let's start out with our most common application of elasticity. And that is the so-called price elasticity of demand. So taking one step back, in general, when we're calculating an elasticity in economics, we're measuring the percentage change in one variable divided by the percentage change in something else. But at least for our purposes, and really quite generally in economics, anytime we do this, we're putting the percentage change in quantity in the numerator. And then we're saying, okay, how does a quantity respond to something else changing? So the price elasticity of demand, what we're talking about here is, we want to measure how much quantity demanded changes when there is a change in the price of the product. Now, if you're eagle-eyed, you'll notice one extra bit here. We've got some absolute value bars on this equation. So this is a slightly annoying convention we have in economics. Consider the law of demand. When the price of a product increases, quantity demanded typically decreases, or maybe stays the same. So if we were to calculate the elasticity of demand with respect to price using conventional mathematics, we would have, if price, for example, increases, positive percentage change, we'd have a negative percentage change on quantity. Those two variables typically move in opposite directions, so you would always get a negative price elasticity of demand, as a consequence of which, again, we have this convention. For the price elasticity of demand, we report the absolute value. We drop that negative sign off. Now, what's slightly annoying about this? That's not the case for all elasticities. Sometimes it matters if these variables are moving in the same or opposite directions, so we want to keep track of that sign. It's only this one special case, which is also the most common case, where we drop off the minus sign. So we'll make sure to keep good track of that. Let's go ahead and get into our first example then. So here is an example demand curve where we want to calculate the price elasticity of demand. Again, percentage change in quantity demanded over percentage change in price. But then let me highlight and emphasize, for those percentage changes, we are also using the midpoint method. So each of those variables in our equation, for example, percentage change quantity demanded, itself is a whole formula. We're taking the difference between our variables and dividing by the middle. So when you do this yourself, I really recommend start out by writing down the overall equation, percent change quantity demanded over percent change in price, and then work out each of those in turn, because you don't want to sort of get lost, lose track of the fact that you've only done half of the problem and report that as your answer. So step by step, let's go ahead with the example of going from point A to point B on this demand curve. And let's start out by doing the percentage change in quantity demanded. So what do we have here? 3,000 at point A, 2,800 at point B. We're calculating a percentage change in quantity demanded, so the only numbers we're using are the quantity numbers. Ignore those price figures for a second. We're taking our two quantity numbers, 2,800 minus 3,000, and minus start. This is a negative change. And then we're dividing by the middle of those two numbers. So that one isn't displayed. You got to work out the middle yourself. In this case, of course, 2,900. So if we go ahead and punch that into our calculator, difference of 200 over middle of 2,900, that comes out to be, rounding to significant digits here, approximately negative 0.0690, which we then convert into a percentage change. So 2 points to the right for the decimal, that's negative 6.90%. That's the quantity side. Let's go ahead and do the price side. Again, let me emphasize, when we're working out the percent change in price, we are only going to use those price figures. So $60 and $70 going from A to B. This one, of course, is going to be an increase. So endpoint $70 minus start point $60 over the middle 65. Notice I've omitted the dollar signs here. Those are going to cancel out because they're in the numerator and the denominator. By the time we're done calculating this elasticity, it will have no units at all, just two relative changes to one another. All right, so 70 minus 60, that's a 10 unit change. We're going to go ahead and divide that by 65. Our calculator tells us rounded to three significance digits. That's 0.154. Convert into a percentage change, 15.4%. And of course, now that we've got our two percentage changes, we're not done yet. We still have to calculate the actual elasticity. So we start with our percentage change in quantity demanded, 6.90, divide by the percentage change in price, 15.4%, and then the result, typically, demand curve, would be a negative number, except we take the absolute value to cancel that right out. Once again, the units are gone, and those percentages are about to cancel as well. So when we report our results, it's going to be 0.448, no units, and then take off that negative sign. We're going to report it as a positive number. So that's our first example of a price elasticity of demand. In a future lecture, we're going to have a look at what we can actually do with that. But for now, let me just allow you to categorize this a little bit, put it in perspective. So we got a number, a unitless decimal number. What does this thing mean? In general, we categorize our price elasticities of demand into three major buckets, and they all revolve around the number 1. If the price elasticity of demand comes out to be exactly the number 1, that's a unitary elasticity. You may recall that's one of the criteria for this measure to begin with. We want something that works out to be equal to 1 when the revenue between 2 points is equal. So we'll use that down the line. But everything is relative to this number 1. So if our elasticity number comes out to be greater than 1, we would refer to this higher elasticity as elastic. And if it comes out lower than 1, that would be inelastic, a relatively low elasticity. So again, over 1, relatively high, under 1, relatively low. And what was our first example here? Well, 0 point, we were under the number 1. So our result here would be referred to as inelastic. Would you like to try this again? Do another example? Of course you would. So let's go back to this demand curve and now look at points G and H. Again, we're going to be careful and start out by writing down our equation. Absolute value of percentage change quantity demanded over percentage change price. And then we'll be careful to do each of these two calculations separately and stepwise. So let's start out with our quantity demanded. We've got two numbers we're looking at, 1600 and 1800. 1600 is our end value, so 1600 minus 1800 divided by the middle of those two numbers. Not of anything else on the graph, definitely not involving price. And of course gives us a 200 unit change divided by 1700. Punch it in your calculator, negative 0.118 after some light rounding. Convert into percentage change, negative 11.8%. Next comes the price, so let's identify our price values, 120, 130. It's the only numbers we're going to use in this calculation. Percentage change price, 130 minus 120. We're looking at an increase this time around, divided by the middle, 125 of course. So that's a $10 change over a 125 middle. That one happens to come out to be exactly 0.08, which is of course 8%. So let's remember, we now have two percentage changes. Neither one of those are in elasticity yet. Let's return to our elasticity formula, plug it in, negative 11.8% change on quantity demanded, caused by an 8% increase in price. That gives us an unitless elasticity of, after taking off the minus sign, 1.48. 1.48. So this time we were above the magic number 1. That makes this elasticity relatively high. And we are going to call it elastic. A little bit of a hidden lesson here. Notice we were just calculating two elasticities along a straight line. That is the demand curve. Now, if you were calculating the slope along a straight line, you would, of course, get the same answer in between any 2 points. That's what a straight line is. It's got the same slope up and down. Elasticity? Not so much. You end up with a different elasticity along any single 2 points of that straight line I just showed you. So if you have to calculate the elasticity between 2 points, use exactly those 2 points, or it can go quite wrong. So this is the price elasticity of demand. It's the elasticity we'll be using the most, but let's also have a look at price elasticity of supply, among other reasons, just to get a little bit more practice in, and also to look at a supply curve that's a little less generic. Look at this supply curve. It's got some wonderful curvature to it. So as I mentioned, what's super nice about this elasticity calculation is that we can calculate it between 2 points, even if we know nothing about the underlying equation. For that straight line demand curve, we could have figured out what the y equals mx plus b of that situation is. This supply curve? I don't even want to try. So instead, if we want to work with A and B here, let's just work with A and B. Let's start out by writing down our formula. Percentage change quantity supplied divided by percentage change price. Notice, no absolute value bars this time. Those absolute value bars only happen with the price elasticity of demand. Otherwise, we're going to track our signs every time. But of course, with a supply curve, we totally expect that thing to slope upward, quantity supplied and price to move in the same direction, the law of supply to apply, so the number should just naturally work out to be a positive number. Let's check. So percentage change quantity supplied first. I'd always recommend start with the percentage change in the quantity because that's going to go into your numerator. Less likely you'll make a mistake that way. What are our quantities here? Well, we've got 13 and 10, 13 being our end value. So it's going to be a 3-unit increase over the middle between those two, 11.5. If you ever have a little trouble finding the middle, keep in mind you can add those two numbers up and divide by 2. 13 plus 10, 23 divided by 2, 11.5. But I don't like to put all that into the equation because then there's entirely too much going on in the equation. So 3 units divided by 11.5, after some light rounding, comes out to be 0.261, which is, of course, 26.1%. Whoopsie, look at those old quantities sneaking in there. All right, let's go ahead and do the same over on the price side. We've got a $700 endpoint, $650 start point. That's a $50 change over a $675 middle, giving us, after some light rounding, 0.0741 or 7.41%. Let's go ahead, based on that, calculate our price elasticity of supply. So we're observing here that we have a 26.1% change in quantity caused by a 7.41% change in price. Relative to the change in price, quantity moves much more. And that, of course, is what we call elastic, because the number is greater than 1. So these labels, that's not just the price elasticity of demand, that's all elasticities. Bigger than 1 is elastic, less than 1 is inelastic. And that concludes our first module on elasticity. In this module, you learned how to calculate the price elasticity of demand and how to calculate the price elasticity of supply. I will see you next time.